Okay, hi, I'm back. Let's see here. So I was on E, draw a box and whisker plot. So a box and whisker plot, a box plot, is basically this number in a graph. So, or these five numbers. It's the five number summary in a graph. So it has a low and a high, a quartile and a quartile, and the median. So we'd have a little number line here. So the low is 40, so I'll just start that at 40. Maybe I'll count by tens. 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Okay, you put the whisker down to the low, so right there's the edge of the whisker. And then it goes up to 63. 63, you put a box around the quartiles. That's why it's called the box plot. So we're going to have a box between 63 to 109. So 63 is about there to about 109. It's about there, so you draw a box between 63 to 109. Hook the whisker to that. And then the high, 126. So 126 is about right there. Draw a whisker to that. And then you put a line at the median, the 90, like that. That's a box. That's a box plot. It's just the five number summary. Low, first quartile, second quartile, third quartile, high. So what are there any outliers? So we got to remember the outlier formula. An outlier, I can give you a picture of an outlier. And the requirement is it has to be 1.5 times this distance below the edge of the box. So if I measure this distance with my fingers and then kind of crank it up times another half and put it right there, it's down where my thumb is, it would have to be way down there. I can already tell there's not going to be a low box, a low outlier. And if we put it on top, there's not going to be a high one. That's a picture of what it is. But here's the formula. To get the low one, okay, the low one is based off of the first quartile right here, that number. So it's the first quartile minus 1.5 times the IQR. IQR is this interquartile range, which in this case was 46. You could do it all at once on your calculator, remembering that the IQR was Q3 minus Q1, so you can get that number by itself and put it in there, or you can do it on your calculator. So if we wanted to crank it out to see where the lower outlier, what would be considered an outlier of the data? Outlier means it's abnormally low. Okay, so Q1 was 63 minus 1.5 times the IQR, which was 46. See, that's at -6. If we did it this way, if you didn't already have the 46 done, you could have done the Q1, which was 63 minus 1.5 times Q3 minus Q1. See, that way the calculator will do the 46 for you. So either way, same thing. So if you already have the if you want to do the IQR by itself, that's fine. If you want to do it all as part of the thing, that's fine too. So the lower outlier was at -6. That means 30, 20, 10, 0. It would have had to. There would have had to been a piece of data in the data set -6 or lower in order for it to actually have been an outlier. And then the upper one. See, the upper one is the same thing, it just has to be higher than the Q3. So the Q3 plus 1.5 times I. Q3 plus 1.5 times IQR. So the third quartile was 109 plus 1.5 times 46. So 109 plus 1.5 times 46. That's 178. So that meant the data, so see, this is 130, 40, 50, 60, 70. There would have had to been a data way out there in order for there to be an outlier. So what are the outliers, if anything? There are none. So an outlier has to be pretty far away in order for all of that to work. And then G, what's the mean and the standard deviation? I mean, you already know how to do that. Stat calculate. So the mean is 86, and so remember, sample is standard deviation, and this little symbol is the population. So here they're basically the same, but it's the S for standard deviation of the sample, 26.67. Okay, frequency So a frequency distribution, what that means is how many of each of these categories there is. There's 125 in this category, there's 271 in this category, and so on. Okay, so it says, what is the mean and standard deviation of the travel time for U.S. adults? I can't remember how she said to get the middle number. You remember because you did it. I can't remember, do we use the middle of this, or of each one of these, or do we do the low? Whatever the number is, usually there's only one number here. But we did a homework, and it was either use the low edge, or the middle, or the high edge, I can't remember. If it was the middle here between 0 and 9 would be 4.5. This would be 14.5. So there's 125 of them. So we need 100, so it's like you have 4.5 plus 4.5 plus 4.5 plus 4.5 plus 4.5 plus 14.5. You got to add them all up. 125 of these, 271 of these, 186 of these, and so on. So we can do it like this. So it could be 125 of the 4.5s. Plus 271 times the 14.5s plus 186 of that middle. So that would be 24.5 plus 121 of the 34.5. Now, like I say, the middle might not be what we're going for here. I'm picking the middle. I can't remember if you were supposed to pick the low edge. So adjust that. So plus 55 of the 44.5s. Oops, it was 54 of those. Plus 62 of the 54.5s. Okay, I just messed it all up. Okay, let's see. There's 121 of the 34s. Okay, that's that one. Need 54 of the 44s. Then I need 62 of the 54s. And then 43 of the 64s, and 20 of the 74s. Okay, so whatever number that adds up to 23,269, and now we got, that's like we added them all up, and now there were 895 of them, so we'll divide that by 895. So the average here would be 26. 25.9988, so basically 26. Okay, there is one, let's see. There is another way to do that on your calculator that's faster. I can show it to you. If you go to Stat and put that data in List 1 and List 2. So again, you got to figure out whatever the number was. Actually, okay, I think I do remember. Don't you add those two up and cut it in half? So 0 plus 10, cut in half. So I think we should have used a 5 there. That probably was 15, 20 to 30. That was probably 25. Yeah, that's what it was. That was a 30, 35. That was a 45. 55, 65, and 75. We should have done that. But I bet it's still probably almost 26. Okay, so here's how you can have your calculator do that. Put these numbers in list 1. 5, 15, 25, 35, 45, 55, 65, and 75. Then put how many of each one in list 2 right next to it. So the 5 had 125. So on my calculator, the 5 has 125. And then the 15 had 271. And then 186, and 121, and 54, and 62, and 43, and 20. Okay, so these are the numbers, these are the how many, the frequency. Frequency means how many. Okay, then just go to stat, calculate, 2 variable stats. And then you would say list 1 comma list 2. On my calculator it does it like that, list 1 and list 2. You would put it in as list 1 comma list 2. And so it looks like the average was really 40. I must have messed up that other one. So okay, the average is 40. That's a lot faster, easier way to do it. Yeah, it's just a lot faster and easier way to do it. And then it also gives you the standard deviation and a bunch of other junk that you don't really need, but it also gives you the minimum and the maximum. So that's another way to do it. Whoops, and I didn't even do it all, so it actually needed the next, it needed one more. There were 13 of them in the 85s section. Looks like the average was 45. And the standard deviation is 27, so it gives you all that stuff. So what's the mean and standard deviation? So the mean was 45. The standard deviation of a sample is 25.82. And I used the sample because there were 895 adults. That's not all of the U.S. That was a sample of the U.S. So we didn't use the population standard deviation. We used the sample's standard deviation. Okay, what's the relative frequency? Remember, relative means percentage, so they just want you to come over here and turn all this stuff into a percentage. So since there were 895 of them, we just have to divide them all by 895. So 125 divided by 895. So that's 14%. 271 divided by 895, 30.3%. 186 divided by 895, 20.8%. Got the idea there? Okay, 13.5%, and so on. So keep doing that all the way down, and that's what relative frequency is. Draw a histogram of the data. Okay, so the histogram of the data, all right. So we just do the same old, so the bars, we have a 0 to 9 bar, so we'll call this one 0 to 9. And then we have a 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, and 80 to 89. Those were the categories. Okay, this category went up to 125. So the highest is going up is 271. So I don't know, we can maybe 50, 100, 150, 200, 250, 300, something like that. So the very first bar goes up to 125. And then the next bar goes up to 271. Now for a histogram, you hook them together like that, they touch. So don't put any space in between there, or else that makes it a bar chart. 186 is the next one. Got the idea? 121 is the next one. 54, then 62. Then 43 and 20. And then the last one was 13. Yeah, so I should have lined this up. So those go there. That's the 60s. This one is the 70s. And then this is the 80s. Okay, so the idea here is you can see that it's skewed. So see the skier is skiing down to the right. This is a right skew. The tail is pulled to the right. That's what skew is. So this is skewed to the right. Use the empirical rule, 68% of drivers, what range of the time? Okay, remember 68, it's not normal, but they still use this a lot of the time. Between 1 and 1 is 68%. Okay, so that means the average plus and minus 1 standard deviation, 1 step. So 1 step up and 1 step down should hold the middle 68. So we have that kind of stuff. The average was right here and the deviation was right here. So 45 minus that is the low, is this edge, is the low edge. So 45 is the average minus the standard deviation. So the low edge is 19. The high edge is plus that, 45 plus 25.82. $70.84. So we write that as use the empirical rule. So it's 1918 through 7084. That will hold the middle 68% of drivers. According to what percent of drivers travels more than 65.9 minutes to work? Okay, so empirical rule. Let's remember what all that junk is. Okay, the average was 45. 1 step up, so 1 step up, 1 standard deviation up was 70.84. 1 step down was 19.18. 2 steps up, so if I add another 25.82 to that, it's 96.64. Okay, I need to check my average. Hold on one, that just doesn't quite seem right. If you already see that I made a mistake someplace, I'm just checking the data. 5, 20, 15, 25, 35, 45, 55, 65, 75, 85. And then it was, oh yeah, that very first one, dang it, 125. The very first one should have been 125. Okay, so if you had that already figured out, sorry, I did the wrong data number there. So stat, calculate 2 variable stats. Okay, dang it, the average, how do I still have an average of 45? It's weird that that didn't change anything. Okay. $186, $121, $54, $62, $43, $20, and $13. I may have told you how to do it wrong. Okay. Don't push two variable stats, I'm sorry. It's one variable stats. You push stat, calculate one variable stats, Chandler. And then you say list 1, list 2. So you would type it in as list 1, comma, list 2. So on yours, you'll say one variable stat, just like always. When you hit in, and then when it asks for stuff, it's list 1, comma, list 2. Okay, there's the deadgum average. It was 27.7. And then the standard deviation is 19.1. Okay. That doesn't do anything to this, but it will change this. Where's the middle 68%? So right in here is the middle 68%. That's one up and one down. So now let's change these numbers. So the middle was 27.7. Then when I go up 19.1, the high end is 46.8. So that's the high end of this one. The middle 68% has a high end of 46.8. And then 27.7 minus 1. Minus 1 standard deviation. The low end is 8.6. Okay, that's the middle 68%. Okay, now this question, what percentage of travelers travel more than 65.9? So let's go up one more from that 46.8. Go up one more of 19.1. Well, that's 65.9, which just happens to be that number. That's how come I knew it was wrong, because I knew that question was going to end up right on one of those edges. Okay, so what percentage of travelers are more than that? So remember, this was one step down, one step up. That's what a z-score is. This is 2 steps down and 2 steps up. Remember, 2 up and 2 down holds 95% of all of the cases. So see how that leaves 2.5% there and 2.5% there? Because there's 5% left for the super far out tails. So they want to know more than this spot right here would be 2.5%. If they ever ask you for between 1 step and 2 steps, that's 13.5. And now all of that adds up to 95. Okay, sorry I messed up that. Hopefully that didn't get you too confused. Okay, babies are born with an average of this. So here's the average and a standard deviation of this. Now, it looks like to me they're talking about all babies, so this is probably the population one. It doesn't really matter since they're not going to have to calculate it, but that probably is the population, not a sample. Babies born after 40 weeks have a, oh, so this is 32 to 35 weeks. Okay, and then 40 weeks, 40 plus weeks, we have an average of 3,500 with a standard deviation of 470. See how they're heavier and they're tighter, they're not as spread out. Suppose 34-week gestation period, so under an early baby weighs 3,000 and a late baby is 3,900. What's the z-score for each? Okay, so z-score is what they're talking about, their score, 3,000 minus the average divided by the deviation. So it's 400 divided by 660. Now if you do it on your calculator, you got to make it do the subtraction first. So it's 3,000 minus 2,600, make it do the subtraction, then divide it by 660. So 0.6. And then this one, it's what they're talking about, 3,900 minus the average, 3,500, divided by the standard deviation. So the top is 400 again. See, both babies were over by 400, but this spread is different. So that z-score is 0.85. Now I just want to show you the comparison here. See the point, so that would be like 1, that would be -1. So they're both in the middle section, they're both in the middle range, but here's the older one at 85, and here's the younger one at 61. So the older one was a little bit heavier relative to everybody else. Okay, I gotta pause right there, hang on.